Happy Thursday, Algebra 2 students. Thank you for clicking on this video. I'm just going to go through a few quick problems to recap what you saw in the 2-4 day 1 video. The first thing the video talked about was how you solve given an x squared and when it's equal to a negative. And so we talked about how, yes, to deal with a square, you square both sides. But the problem is that we can't take the square root of a negative. So we decided to break this apart as the square root of 16 times the square root of -1. So you can break apart two radicals, or one number as two radicals. And the reason we do that is because one of the big learnings was that you need to know that I is the same as the square root of -1. So you were introduced to this idea of an imaginary number. So when we take square root of both sides, we get x equals plus or minus. We can break it apart. And so our final answer here would be x equals plus or minus square root of 16 is 4. And we now replace the square root of -1 with an I. One quick thing, just so you know, you don't have to show this work in between. Anytime I see a negative, I just automatically take an I out. So I don't always, if I was doing this on my own and not teaching, I went right to the square root of a -1. All right. Letter B is one step more complex, okay? So when we square root that, again, we could take the square root of 56 times the square root of -1, but then the problem also got into simplifying radicals a little bit further. So not only do we take out the -1, but we can also think about if I can break 56 apart as a perfect square times something. And I know that 56 is 4 times 14. So in this case, I get x is equal to plus or minus square root of 4 times the square root of 14 times square root of -1. When I go to rewrite that, plus or minus, square root of -1, again, is I, and square root of 4 is 2. So I put the 2i in front, root 14. Okay, so that was the first thing the video dealt with. Again, if you didn't watch it last night, that was probably very confusing, but we are introduced to this I, an imaginary number, which is the square root of -1, and we reviewed how to break things apart. Okay, the next thing we talked about are complex numbers. Complex numbers are of the form a plus bi, so we spent some time adding, subtracting, and multiplying them. This next example is a subtraction one because I see the minus in the middle, or it could say find the difference of 2. And in this case, you just need to be careful to distribute that negative through. So I would rewrite this as 8 plus 3i minus a negative is plus 2 minus a negative is plus 7i. Once you do that, what the video talked about is it's just like combining like terms. So I'm going to add the two numbers together. 8 plus 2 is 10. Then I'm going to add the things with the i's, the imaginary parts together. And 3i plus 7i is 10i. Sorry, looking at my answer key. It was wrong. Okay, I think we're right there. Okay, so if you have the minus, you get 10i. All right, so again, this is what the purple part became, and if you're a visual person with colors, the yellow part became that 10. All right, next, I'm going to add two complex numbers. Once again, I add the real parts. Now, these parentheses don't matter. If I wanted to, I could rewrite it without it. I would not have to. Okay, so once again, I do the 5 plus the 1, and I end up with 6. And then I would take the -2 plus 9. So -2i plus 9i would be plus 7i. So that would be my answer there. So it's very much like adding like terms. Instead of things having x's attached to them, if they have an I attached, you combine them. Last but not least, we talked about in the video finding the product, which means multiply to get in the form a plus bi. The first way we talked about it is to distribute if you have just a single term times a binomial. So this would give me 3/5 times 20, and then minus 3/5 times 4/3 I. Okay? Now I do want to make sure, you can put the I in parentheses if you want, we do need to understand how to multiply fractions. You could multiply top times top, bottom times bottom, and then divide. Or one thing that's going to help you be more efficient is that since we're multiplying, you are allowed to cancel across. So 3 is not divisible by 5, but 20 is. So I can do 20 divided by 5, which is 4. So 3 times 4 gives me 12 minus, and then same thing here. I can't do 3 divided by 5, but this 3 can cancel with this 3. So then when I multiply across, I'm just left with 4 over 5i. That would be my final answer. Okay, so it doesn't have to be pretty. Sometimes it does end up with fractions, but you still want the two pieces. The real part, which is the a, it does not have an I attached to it, and the imaginary part is the BI. Okay, last but not least, we could do a binomial, 2 terms times 2 terms, or a full complex number times full complex number. We would use the idea of distribution. 4 times 4 is 16. 4 times negative I is minus 4i. Then I go to my insides. I times 4 is plus 4i, and then I times negative I is negative I squared. As we did this, we see that the minus 4 plus 4i, those are going to cancel out. But now we've got this weird I squared. Now we already said I is the square root of negative 1. So what this video showed, if I want to get rid of the square or square root, I would square it. So that means that I squared actually equals negative 1. So what the video talked about is anytime you see an I squared in a problem, you're going to replace it with a negative 1. So I'm going to turn this into a negative 1. So I have the 16 minus, but then the I squared is negative 1. 16 minus a negative would be the same as 16 plus 1, so 17 is my final answer. So you can see that sometimes when we multiply a complex number times a complex number, we actually end up with just a real number without an imaginary part. We'll talk more about that tomorrow or in tonight's video. Okay, last but not least, let's try one more. Distribute 2 to the 4. 2 times 4 is 8. 2 times negative 5i is minus 10i. Okay, in this case, I go inside times inside. 3 times 4 is 12, so plus 12i. And finally, 3 times negative 5 is negative 15, but I times I is I squared. This time, those middle terms don't cancel out. I'm left with 8. And then these two can combine. So negative 10 plus 12 is plus 2i minus 15. But don't forget, I'm going to change the I squared to a negative 1. Okay, so I have times negative 1. Scroll up. So I now have 8 plus 2i. A negative 15 times a negative 1 is plus 15. Last but not least, I'll combine these. I end up with 23 plus 2i. And that's your final answer for that one. Okay, here's what I need you to do now. You need to go straight to the your Pearson account and find the 2-4 Day 1 Pearson practice. Remember, you need to work on that, hopefully finish it. But no matter what, when your class period ends, I need you to submit what you have done. Okay, if you do finish that before the end of class time, you would move on to watch the 2-4 Day 2 recap. But remember, if you do not submit that by the end of the hour, your Pearson practice, you will be counted absent. Thanks so much, and we will see you hopefully tomorrow. Thanks. Bye.